Good morning, all of you. Okay, in the previous lecture, we have seen the simply supported beam. Okay, today we will going on the next type of the beam, overhang beam. Okay, overhang beam. What is mean by overhang beam? The beam which is just rest behind its support, either one side or both sides. That this beam is called as a overhang beam. Okay, this is the one of the type of the overhang beam. Okay, see this numerical is given. Here you have given the A to B. There is a UDL is at. Then B to C again UDL is at. Okay, 6 kilonewton per meter. Then distance is given 2 meter from A to B, and B to C you have given the 4 meter. C to D there is no load, the distance is given 2 meter, and at the D point there is one couple is given. Okay, our load, horizontal load is at 10 kilonewton at a distance 0.5 meter, and below also same 6 kilonewton load is at a same distance 0.5 meter, and D to E there is no load. Then how to solve, how to draw the SFD BMD, as well as how to find out the maximum bending moment. Okay, we'll see. First we want to find out the support reaction. Okay, before going on the support reaction, you have to convert this load into the couple. Then how to convert this load into the couple? Guys, see, this load is going in which direction? In this way they are swing. Again pattern type of the load is given. This is going clockwise direction. Then how to convert into the couple? Force into distance. How much force is given? 10 kilonewton. Okay, 10 kilonewton into 0.5. You will get how much? 5 kilonewton. And which direction? Again clockwise direction. And this one 6 kilonewton again going clockwise direction. 6 into 0.5, there is a 3 kilonewton. Means if you are making the summation, there are two couple, 5 kilonewton and 3 kilonewton. We lack only one couple. Both are going clockwise direction. 5 plus 3, you will get the total couple. On that point 8 kilonewton. In which direction? Here is a 8 kilonewton. In which direction? Clockwise direction. Okay, this is very important. When you given the pattern type of the load, then you have to convert that load into the couple. Okay, all of you getting? Then same procedure for the support reaction. I will convert vertical is positive for summation of Fy is equal to 0. Right? Summation of Fy is equal to 0. And check that where is the vertical forces. I will consider here at the roller support RB, and here is a RE. Its support RE. There are two vertical forces are given at point B and at point E. That's why I will write RB plus RE. Right? Then see again, here is the UDL is at A to C. Okay. Then I will write the total force at the A to C. How to calculate this? Force into again distance. You will get the point load at the CG. 2 plus 4, you will get the 6. 6 into 6. Okay, but they are acting downward direction. That's why I consider the minus. 6 into 6. Okay, 36 is there. Okay, right. I will write the RB plus RE is equal to what? 36 kilonewton. Right? Total load. You will get the first equation. Then what do you have to do? Then you have to take the movement, summation of the movement at B point, either B support or either E support, any one support. I will take the support summation of M E is equal to 0. I will consider this support. If you have considered the B point, you will get the same answer. Okay, clockwise, I will consider the positive. Then check that summation of ME is equal to 0. Okay, then we are going to which direction? Positive direction. Right side direction. ME is equal to 0. We'll check that this RB, check that first I will take this load RB into what? Up to the distance E point. 4 plus 2 plus 2. You will get the 8. Okay, RB is going clockwise direction. That's why RB into 8 is there. RB into 8 is there. Is there any another force is that? Yes. At the point A to C, there is a UDL 6 kilonewton meter UDL is that. Okay. If you have converted into the point load, then 6 into 6, you will get this one, 36. Right. And where is that? Here, 36. From the 3 meter from A and 3 meter from the C, 36 kilonewton. Right. This is again going anti-clockwise direction. That's why minus what? 36 into what? Where is that? What is the distance? This 3 meter plus 2 meter plus 2 meter. 2 plus 4 plus 3 7. Okay, 7 meter is there. Then you will get the 36 into 7 is there. Right. And here is a couple is at in which direction? Clockwise direction. That's why we will consider the couple when you calculate the summation of movement. Okay, this is the 8 kilonewton meter is there. 8 kilonewton meter is there. Then check that equal to 0. Then when you calculate this, then you will get the RB is equal to, you will get that value RB is equal to 30.5 kilonewton. 30.5 kilonewton. If you have put this value in this equation, then you will get the RA is equal to this 5.5. Means 36 minus 30.5. Then you will get the RB is equal to 5.5 kilonewton. Check that. You will get the both support reaction RB and RE. Okay, once you have got the RB and RE value, then easily you can calculate the SFD calculations. Next part is the SFD calculations. Okay, all of you getting how to calculate the support reaction? Yes, same procedure is there. Then SF calculations. Check that. When you do the SF calculations, then you have to check SF at A point is 0 and SF at E point is 0. SF at A point is 0. Okay. Then you have to think about the B point. SF at B point, we will consider the just left side. Okay. SF at B point, just left side, because here there is no any load. That's why you will get the only one value. For the C also you will get the only one value for the SF calculations. SF at B, just left side. We will consider this part, just left side. Right. How much load is that? We will consider only the 2 meter. This 6 into 2, 12. And how to add this? In downward direction. That's why minus 12 kilonewton. Okay. Then next, SF at B, just right side. We are coming the just right side of the B. Just right side of the B. Then how to calculate this again? See, this one just right side of the B means what? 6. This 6 kilonewton into again 2 kilonewton. Right? Minus, I will write here 6 into 2, you will get again 12 kilonewton. Okay? Then again here is a one more load is that in vertical direction, upward direction, right? This is positive what? RB is equal to what? 30.5 means plus 30.5. You will get the 18.5 kilonewton. 18.5 kilonewton positive load. Then next, SF at C point, because there is no any load. SF at C point, that's why you will get only one point, not left and right. SF at C, check that. We will consider the total load. Yes, we'll consider the total. How much load is that total load? Check that. This 6 into 6, this minus 36 is there because downward 6 into this 2 plus 4, 6, 36. And how much upward load is that? RB is equal to 30 plus 0.5, then you will get what? Minus is there, no? Minus 5.5 kilonewton. You will get the minus 5.5 kilonewton. Okay, then SF at next point, which is the next point? D, there is no any force, that's why we will take the next point. SF at E, just left side, you will get the same load because we have already calculated up to the E point. There is no load in between C to D or D to E, only couple is that. Minus 5.5 kilonewton. And SF at E, just right side, check that, minus 5.5 up to that. And RE again what? 5.5 positive, you will get the 0 kilonewton. This is the SF calculations, very simple. Okay, you have to check this SF calculations. Then I will draw the 0 line. I will mark the point, A point, then B point, then C, D and E point. Okay, I have marked all the points. Then check that SF at A 0, SF at B just left side minus 12 kilonewton. Means here we require the minus, that's why we are coming the downward. Here is UDL is that, that's why we draw which line? Inclined line. Okay, there is a minus 12 kilonewton, right? Then at the same point P, we will get the 2 point, minus 12 kilonewton and just right side 18.5 kilonewton. Okay, means we are coming upward, positive, above the 0 line. Suppose here is a 18.5 kilonewton. Okay, then next B to C again UDL is that, here we will draw the inclined line. SF at C minus 5.5 kilonewton. SF at C, we are coming downward again. Here is a 5.5 kilonewton. Then check that here C to E, there is no any load is that. Okay, so we will travel with the horizontal line or straight line, and here is a plus 5.5 kilonewton is that in upward direction. That's why here is a minus 5.5 and plus 5.5, you will get the 0. This one minus plus minus. Okay, this is your SFD. All of you getting how to draw the SFD? Then we will go on the BM calculations. Okay, once you have calculate SF calculations, then easily you can draw the SFD diagram. Then next is the BM calculations. Okay, BMD calculations. BA, bending moment at A point, you will get the 0. Then check that bending moment at B point. What is the value of bending moment at B point? You have to consider up to this B point. How much load is that? 6 kilonewton meter, and distance is at 2 meter. Means force into distance. When you calculate the moment, then consider the force into distance. This force is going anti-clockwise direction, right? See, this force is that we are travel left to right. This is moving anti-clockwise direction. That's why minus 6 into 2, minus 6 into 2, you will get the minus 12 kilonewton meter is there. Then next point, bending moment at C point. Check that bending moment at C point. Okay. Then again I will consider this UDL is at A to C directly. Check that how much UDL is that? 6 kilonewton per meter. 6 into 6. Okay, and where is that? At the center. Where is the center? 3 meter from the A and 3 meter from the C. Means here, right? Here too we want to the multiply by distance again. Means I will write here minus again 6 into 6, right? This we have converted into the point load, and how much distance will travel from the center? 3 meter up to the sea, okay, into 3 is there, into 3 is there. Means force is at 36 kilonewton and distance is travel 3 meter, right? Then there is one more load is at in clockwise direction, okay, clockwise direction, RB. What is the value of that RB? RB is equal to 30.5, okay, plus 30.5 into how much distance they will travel? B to C, 4 meter. Then if you have calculate this bending moment at C, then you will get the positive 14 kilonewton meter. 14 kilonewton meter. Then next bending moment at D point. See, D point having the couple. That's why you get the 2 points again for the left side and right side. Bending moment at D point, just left side. Okay. Again similar way, I will convert this UDL into point load. 6 into 6, 36 is there. Okay. Minus 6 into 6 point load. And where is that? At the CG, 3 meter from the A. Okay. And what is the remaining distance? 3 meter plus 2 meter up to the D. Means total distance is a 5 meter. 3 plus 2. You will get the 5 meter. Then again one more load is that in the clockwise direction, 30.5 into what is the distance? This 4 meter plus 2 meter. You will get the 6. Is there any load in that? Just left side, no. Then you will get the bending moment at D point, just left side. You will get the 3 kilonewton meter is there. 3 kilonewton meter is there. Then you have to calculate the bending moment at D, just right side. Means we have calculated at the same point. We have the 3 kilonewton meter is there. If you are coming the just right side, then plus 8 kilonewton meter is there. Plus 8. Okay, means you will get the 11 kilonewton meter is there. Okay, and bending moment at last point, E point is equal to 0. You will get the bending moment at E point is equal to 0. Once you have got get the calculations, then you can easily draw the bending moment diagram. I will show you here. First draw the 0 line. Okay. Then give the name of the point A, B, C, D and E point. Check that bending moment at A point 0, bending moment at B point minus 12 kilonewton. Okay, minus 12 kilonewton meter is there. If you have drawn here inclined line, then you should draw here parabolic curve, or we can say the second degree curve. Okay, you have to draw the negative curve, don't draw the positive curve. Negative is there. This value is a 12 kilonewton meter is there. Okay. Then next point, bending moment at C point. Check that 14 kilonewton meter is there. Where is the C point? We'll get the positive. Here, when you draw the inclined line in SFD, then draw the parabolic curve in the BMD. Okay. Suppose here is a 14 kilonewton. I will draw the second degree parabolic curve. Okay. Here is a 14 kilonewton meter is there. Then after that, check that bending moment at the D point, just left side. We have the 3 kilonewton meter is there. Here we have drawn the horizontal line. Then we will draw here inclined line. What is the value of that? 3 kilonewton. Okay. This value also positive. 3 kilonewton meter. Then same point we will get the 11 kilonewton meter. Means we are going the upward direction. Suppose here is a 11 kilonewton meter. And last point, E point, we have the bending moment at E point 0. Again here is the horizontal line. Then we will join with the inclined line. This is the bending moment diagram, BMD. Okay. Then see where we will get the point of contraction, or where we will get the maximum bending moment. Here you have to calculate the maximum bending moment. Where we get the maximum bending moment? where is the shear force is 0, that point will get the maximum bending moment. This point. Okay, we don't know the distance from the A point. We want to calculate the distance. Okay, how to calculate? Last lecture I have told. Here, if you are getting the two triangle, then use the triangular similarity principle. Okay, check that in the SFD. We have the two triangle, this one and this one. We will consider that two triangle. Okay, I will draw here that two triangle. Use the similarity. If you have triangle principle. Similarity of the triangle principle. Okay, what is the similarity of the triangle principle? See, I will draw here this triangle as it is. 18.5 kilonewton one side, and this side we have the value 5.5 kilonewton. But we don't know this distance. We will consider this distance is A from the B point to the this shear force 0 point. Okay, here is a, we will consider this is the distance A. Okay, and what is the total distance? 4 meter. B to C 4 meter is there. We know the total distance. This is B to C is 4 meter. Then what is this remaining distance? 4 minus A is there. 4 minus A is there. Right? Then easily you can calculate this value. How to calculate this? You have to take A divided by what? A divided by 18.5 is equal to 4 minus A divided by 5.5 is there. If you have calculated A is equal to, then you will get the 3.08 meter from B point. From B point. Right? B person, you will get the distance 3.08 meter. Okay. Then, what is the distance from the A point? This you have to add in this value. Hence, we can consider the x is equal to 3.08 plus 2. You will get the 5.08 meter from A point. Okay, we have calculated the distance. This distance, total distance is 5.08 meter. Okay, we will consider the maximum bending moment at the section XX. Okay, bending moment at the section XX. Then you will get the maximum bending moment at the section XX. How to calculate? Then again you have to take the bending moment about the section XX. Then how to calculate this bending moment about the section XX? Okay, this value you have to calculate. Check that this load, how much load is that? 6 kilonewton. In which direction? Downward direction. Minus 6 into what? Total distance up to this point 5.08 into 5.08. And where is that this up to this point? Half distance. 5.08 divided by 2. Right? Again, how much load is that? Check that. Again, is there any force is that? Here is a RB is that plus how much force is that? 30.5 into what is the remaining distance? Minus 2 meter, means you will get the 3.08. 3.08. Right? All of you check that. This is correct. Then you will get the bending moment, maximum bending moment at the section XX is equal to you will get this value 16.52 kilonewton meter. Okay, this is your answer. Here you will get the value 16.52 kilonewton meter. Okay guys, same procedure is given. Don't confuse. When you calculate the bending moment, when you calculate the support reaction for the given beam, if you have given the overhang beam, then you have to consider only the summation of the moment at any one support, E support or B support. You will get the same value. Don't confuse. Other procedure are same. Today we will stop here. Next lecture we will solve some numericals. Okay.